Copy 724, right. Center maintain 2000.
Center maintain 2074.
Comment 504 to center maintain 3000.
3000, comment 504.
In this video, we're going to be covering weight and balance. This is going to be comparatively a small video. We're going to start covering with a few definitions here. An empty weight gross weight, useful load, arm, moment, center of gravity, and datum. Empty weight is the weight of the airframe, engines, and basically all permanently installed equipment. An unusable fuel. If there is a fuel which goes in the wings and some quantity of it which cannot be used, or that is also gonna be considered as an empty weight. The gross weight is the maximum allowable weight of both the airplane and its contents. Basically, the empty weight plus the useful load is gonna be equal to the gross weight. But the useful load is the weight of the pilot, co-pilot, passengers, baggage, then usable fuel, and also the drainable oil. Everything is considered. Like the useful load. Arm. Before arm, let's just cover the datum first. So let's say if this is the plane, right? So, and that's the cockpit. So there is an imaginary line, and this is basically coming from the manufacturer. Datum is an imaginary vertical plane, and all the arm measurements are taken through this datum line, and it is established by the manufacturer. What is an arm now? It's the horizontal distance in inches with reference to the line to the center, reference to the datum line to the center of gravity of its item. So let's say if there is a passenger here, right? I want to know what is the arm of that passenger. So the datum line doesn't change. It's an imaginary line established by the manufacturer. It's gonna go in the horizontal axis like this, and let's say the CG, depending on the total weight of the plane, the center of gravity, comes out to be here. Then the distance from this CG to any place is gonna be the arm of that place or person. So if I want to know the arm of that of this man sitting in there, that would be the distance in inches from the center of gravity to the distance on the datum line. Okay, the moment is the product of the weight of an item multiplied by its arm. So if that man has, like, let's say 190 pounds weight, that multiplied by the distance in the arm, which would be this distance, right? That would be known as moment. Center of gravity is the point about which an aircraft would balance if it were possible to suspend it at that point. So basically, if you put something, imagine, like, just an imagination here, if you put the whole, with all the load and everything, if there is a structure or a long rod underneath that, the whole plane is gonna be able to balance on that rod or on that structure. That point is known as the center of gravity, where basically it balances itself. Okay, what is the basic equation used? Like, what is the relationship between this weight balance problems, right? So weight and balance, famous equation, right? So remember this term. Basically, the equation goes like this: that the weight multiplied by arm, as I told you, that the arm is the distance in inches from of that thing from the center of gravity on the datum line, is equal to moment. So you can also think of WAM as an acronym, that this multiplied by W multiplied by A is equal to M. And then the same thing, you can actually see it in multiple ways, that the arm is gonna be equal to the moment over weight and whatnot. Maybe the weight is equal to moment over arm. Okay, so what are the effects of overloading an airplane? So basically it's a long list. I'm just gonna say it out. Basically, if the plane is overloaded, you're gonna need a higher takeoff speed. So it's gonna become the takeoff speed at which the airplane is recommended to take off. It's gonna become more. The speed is gonna become high, and the takeoff run. The second is the takeoff run is gonna become longer. Third is the reduced rate and angle of climb. Fourth is the lower maximum altitude. The maximum altitude which an airplane can reach is gonna become less. Shorter range, like you won't be able to fly the airplane. Like the overall range, or the mileage is gonna become less. Reduced cruising speed, reduced maneuverability, higher stalling speed, higher landing speed, and longer landing roll. Just like we had issues when we were taking off, we're gonna start having issues when we were landing. And also, like, there's an excessive weight or pressure on the nose wheel. Okay. Now we're gonna be covering about the forward center of gravity effects, and then the rear center of gravity effect. So what happens if the center of gravity is very, like, if this is the plane, right? Okay, if this is the plane and the center of gravity is far suggested, or maybe uh, normal as this one, but we lowered the plane so that the center of gravity became this one, right? So what would happen? So again, it's a long list. So basically it boils down to what happens to the stall speed, what happens to the cruise speed, what happens to the stability. These are the basic things. So the stall speed over here is gonna become high if it is, because look, it's already nose down. The center of gravity is very forward, so you can think of it as nose is already gonna be down. Stalls are gonna be really hard. So the stall speed is gonna increase. The speed at which the plane is gonna be stalling needs to be very high. It's gonna be basically uh, it's gonna make the stall speed higher. Okay, and the cruise speed is gonna decrease, because it's not like angle of attack is less now. it's already pointing downward, so the cruise speed is gonna so it's gonna become slower cruise speeds. And stability, plane is gonna be very stable, right? The center of sorry about that. The so it's gonna have a lot of longitudinal stability. And another thing is like the elevator the back elevator pressure is gonna be high too, which is gonna which is what is gonna happen is like you're gonna have longer takeoff rolls, uh, and like the problem with the uh, landing flare too. Okay, what about the rearward center of gravity? What if the center of gravity is here now, right? So again, the stall speeds in this case is gonna be lower. Plane can stall uh, uh, plane can actually stall even at the lower speeds. The cruise speed is gonna be better. It's gonna be uh, it's gonna be more, and the stability is gonna be less. The stability in this case is gonna be less, and like you can expect like easy stalls and easy spins, right? So those are the characteristics. And the last thing I wanted to cover is like what are the standard weights in an airplane? Like if the data is not provided, what would you like what would you assume? So crew and passengers is gonna be equal to 190 pounds. The gas or gasoline uh, is assumed 6 pounds per gallon per US gallon. The oil is 7.5 pounds again per US gallons, and water is considered 8.35 pounds per US gallons. Okay, 8.35 for water, oil is 7.5, gas is 6 pounds per gallon, and then the crew members are the standard weights are taken as 190 pounds. Yeah, thanks for watching.